In many workshops, garages, and backyards, building projects usually begin the same way. A person finds a plan. It might be a printed blueprint, a PDF file, or a set of step-by-step instructions shared online. The plan acts as a map. It defines measurements, materials, and the order of assembly. Most people rely on it without thinking too much about where it came from or how complete it is. Under normal conditions, this system works quietly in the background. Designers create plans. Platforms distribute them. Builders follow them. Hardware stores supply standardized materials that match those instructions. There is a chain behind the process, even if it is not always visible. Digital platforms host the files. Payment systems process access. Manufacturers produce uniform components. Logistics networks move those components into local stores. When everything in that chain is functioning, building feels predictable. You measure, cut, assemble, and expect a certain result. The plan fills the gaps in experience. But that chain is not always stable. Plans can be incomplete, outdated, or simply unavailable. A file might be removed. A design may assume tools or materials that are not easy to find in a specific region. Sometimes instructions skip steps, assuming prior knowledge. Other times, they are overly rigid, leaving no room for adaptation when conditions change. When one part of the chain breaks, the entire process slows down. A missing measurement can stop progress. A specific component that is not available locally can force redesign. In some cases, people abandon projects not because they lack skill, but because the structure they depended on is no longer reliable. To reduce this dependency, builders have developed different approaches. Some rely on modular thinking. Instead of following a single fixed plan, they break projects into smaller, repeatable sections. Each section can be adjusted without affecting the whole. This allows flexibility when materials vary. Others use reference-based building. Instead of one complete plan, they gather multiple sources. A diagram from one place, a measurement from another, and a visual example from somewhere else. The final structure is assembled from these fragments. This method increases adaptability, but it also requires more interpretation. There is also experiential building. This approach relies less on formal plans and more on accumulated practice. Measurements are estimated. Adjustments are made during the process. It works well for those with experience, but it can be difficult for beginners because it lacks clear guidance. Another category involves templated systems. These are simplified frameworks that can be reused across different projects. Instead of a detailed blueprint, they provide proportional relationships. For example, how height relates to width, or how support spacing affects strength. These templates reduce the need for exact plans, but still require understanding of structure. Within these categories, one format has become increasingly practical, especially for individuals working at home or in small workshops. This is the build-from-plan system, designed for adaptability rather than precision replication. This format does not aim to reproduce a single exact object. Instead, it provides a structured method for building a type of project using commonly available materials. The focus shifts from copying a design to understanding how the design functions. At a functional level, this system begins with a material list. Unlike traditional plans that specify exact brands or specialized components, the list focuses on categories: standard wood sizes, basic fasteners, simple tools. The idea is that these items can be sourced in most locations, even if minor variations exist. Next comes the layout. Instead of a rigid blueprint with fixed dimensions, the layout shows relationships between parts. It explains where supports are placed, how load is distributed, and how different sections connect. Measurements are often given as ranges or ratios rather than fixed numbers. Assembly is broken into stages. Each stage focuses on a structural layer. First, the base or frame, then the supports, then the outer structure. This layered approach allows the builder to verify stability at each step before moving forward. In some cases, the system also includes basic wiring or power setups, especially for projects that involve lighting, small motors, or energy use. These sections are usually simplified, showing how components connect rather than requiring advanced technical knowledge. What makes this format structurally different is that it does not depend on exact replication. If a board is slightly shorter, the system can adjust. If a specific fastener is not available, an equivalent can be used. The plan acts more like a guide than a strict instruction set. This makes it suitable for household scale use. A person working with limited tools can still follow the process. The steps are repeatable, and once understood, they can be applied to different projects. Over time, the builder begins to rely less on the plan itself and more on the underlying structure it teaches. These systems can exist in different forms. Sometimes they are presented as finished devices, already assembled and ready to use. In other cases, they are shared as built-from-plan guides. These guides typically include a materials list, an assembly layout, and a sequence of steps. They may also include diagrams that show how components are arranged and how they interact. For someone starting out, this format can serve as a bridge. It provides enough structure to begin building, while still allowing room for adaptation. It does not remove the need for learning, but it changes the way learning happens. Instead of memorizing exact steps, the builder starts to understand patterns. This approach is not a replacement for traditional plans. Detailed blueprints still have value, especially for complex or precision-based projects. But as an additional layer, adaptable build systems can reduce dependency on perfect instructions. They are particularly useful in situations where access to reliable plans is limited, or where materials vary from place to place. They also support experimentation. Small adjustments can be made without restarting the entire project. Over time, this shortens the chain between the builder and the final result. Fewer external dependencies are required. The process becomes more self-contained. For those exploring this method, structured guides do exist that document the full build format step by step. These guides outline the materials, layout, and assembly process in a way that can be followed and adapted. One such format reference is often shared in the video description for those who want to examine how this approach works in practice.